In this tutorial on the theory behind titrations, and specifically acid-base titrations, we're going to see how titrations can be used as a way to determine an unknown concentration of a solution. And this is something, again, we'll talk more about in class, but you'll get an introduction here. We're going to learn about the equivalence point, the theory behind that. We'll find out about the role of an acid-base indicator in a titration, and learn some of the background theory that will be necessary when you go to complete titration calculations. An acid-base titration is a method that can be used to determine both an accurate and precise concentration value for an unknown solution. In order to be able to do that, there are some things that I guess are necessary, or some pieces of information that you need to know. Number one, let's say that you are using an acid to titrate a base, and so you would need to know the volume of the acid and the concentration of the acid, and you would also have to know the volume of the base in order to be able to eventually find the unknown concentration of the base. And if we scroll down here to figure 1, we can see that the situation that I was talking about would have the acid of known concentration in this piece of equipment called a burette, and the base of known, so a known amount or known volume of base of which you don't know the concentration would be in this Erlenmeyer flask. It's important to note that depending on what solution you were trying to find the concentration of, let's say instead you were trying to find an acid, you would have the acid in the Erlenmeyer flask, and you would put the base, of which you know the concentration accurately and precisely, in the burette. But for this situation, as I said, you've got your burette filled with acid of a known concentration, and you're going to add that acid until you reach a certain point known as the equivalence point. And how you know you're at the equivalence point is because the contents of your Erlenmeyer flask, containing, again in this case, your base of unknown concentration, the contents will turn color, and they will turn color because of an indicator that is present. And the acid-base indicator has to be selected based on the type of substances that you're both using to titrate, so your titrant, and the substance that is being titrated. But if it's done properly, if the titration is done properly, the indicator will turn color and correspond to the equivalence point. And so the point at which the indicator turns color is called the end point, and if the end point corresponds or overlaps with the equivalence point, then you will be able to properly titrate a solution. And so you might be asking, well, what is the equivalence point? This is the point in the titration when the number of moles of acid are equal to the number of moles of base. And so again, the equivalence point is where the number of moles of acid that I have added, in this case, would be equal to the number of moles of base that are present in the Erlenmeyer flask. And so to take this from the top here, that if I have my acid of known concentration in my burette, and I continue to add that acid until I see a change in color here, I will be able to measure the volume of acid that was added. So now I know the volume of the acid that was added and the concentration of the acid that was added. Therefore, I can figure out the number of moles of acid that were added. And if I'm only adding acid until I see that color change has occurred, and just right at the moment when I first see that color change and it persists in the solution, then I know that is the point where the equivalence point has been reached. And at the equivalence point, the number of moles of acid are equal to the number of moles of base. And so now I have a solution in the flask that I'm trying to find the concentration of, but I know the number of moles of base that are present in here, and I also know the volume of the solution that I started with, because I would have carefully measured that and added it to the flask. So I know the number of moles of base, I know the volume of base, I can now figure out the concentration of the base, because remember that we have C equal to N over B. And so I just said that for the solution in the flask, I know the number of moles of base that are now present because I can get this from this connection here, this relationship here, and I know the volume of base because I would have measured that before I started titrating. And so in doing that, I can find what the concentration of that solution was at the start of the titration, which is what I'm looking to find by doing the titration. Another piece of information here, and I'll just touch on this really briefly. We'll talk more about this in grade 12 or in 4U chemistry, is the titration curve. And so this, in figure 2, we see examples of a couple of titration curves. And what it does is it shows how the pH of the solution changes as you're adding your titrant. And so in this case, the NaOH is my titrant, or my solution in the burette, whereas in this case here, the HCl is my titrant, or my solution in the burette, so it would be right here. Either way, we see that as the volume of the titrant is changing, so is the pH of the solution. And at a certain point, we reach the equivalence point. Just to note that the equivalence point is not always at pH 7, and again, in grade 12 chemistry, we'll talk a little bit more about that. So as a recap here, we talked about what a titration is and a little bit about how it works. And the key part being this idea of the equivalence point, and that when you reach the equivalence point, the relationship between the number of moles of acid and base is equal, and then we can use that information to allow us to calculate whatever it is we need to calculate by doing the titration. And so some of the ideas that we learned here, we will be able to apply practically when we do titrations in class and get some practice with that. And we will also be able to apply in the calculations when we get problems or when we collect data that will allow us to calculate the unknown concentration of a solution.